Welcome back to WAPSI. So we can go to another section of atomic and nuclear physics. Okay. So the first question is related with the binding energy. Binding energy of a nitrogen nucleus 7n14, as that means ZXA. Z is 7. That means the atomic number is 7 and the mass number is 14. Given M, that means the total mass of this element is 14.00307 U, atomic mass unit U. So we have to find the binding energy. So what is mean by binding energy? Okay, in a nucleus, okay, take one nucleus and some of the mass is distributed by the neutrons and some of them are distributed by the protons, but a defect. By calculating the total mass, we get a defect. That means the individual masses of the neutron is multiplied by the mass of, that means individual number of neutrons is multiplied the mass of neutrons. We get the total mass of neutron. Okay, and then take the number of protons. Then the number of proton is multiplied by the mass of proton. We get the total mass by protons. So we can add that mass of protons, mass of neutron. So we can add the total mass, but the total mass is just less than this mass, calculated mass. So where does this mass goes? That mass is changed to energy. Okay, that mass contributes some energy to bind these nucleons like protons and neutrons, to bind them in a single spherical structure. Okay, that mass is goes to a binding energy. Okay, that mass transformed to an energy format. That energy is called a binding energy. So to do this problem, we must know the individual masses of proton and neutron. Okay, I will write the equation for binding energy first of all, then I will substitute the mass of proton and mass of neutron. So binding energy is given as ZMP. That means Z is number of proton and MP is mass of proton, plus A minus Z. That means mass number minus atomic number, which gives the number of neutrons into mass of neutron, minus mass of that element X. In here the X is nitrogen. Okay, so that is multiplied by 931.5 mega electron volt. Okay, 931.5 mega electron volt is the energy contributed by one nucleon, or the one nucleon, like one atomic mass unit. Okay, 1 AMU. The energy contributed by 1 AMU, one atomic mass unit, is 931.5 mega electron volt. Okay, so we can substitute what is MP. MP is equal to mass of proton. Mass of proton is equal to 1.007 to 7647. 1.007 to 7647 is the atomic mass unit of proton. Okay, and mass of neutron is 1.0087. Okay, in here, in this question, 14 and 7 is the number of protons and 7 is the number of neutrons, because ZXA 7 is the number of proton and 14 minus 7 again gives 7. So 7 is the number of neutrons. So substitute binding energy is equal to 7 into MP plus 7 into Mn minus 14.00307. 14.00307. It is approximately, you want to substitute this mass MP and Mn. Okay, this is approximately 0.105. Okay, approximately 0.1. So just multiply this 0.10. So 0.10, not 1, 0.16. Okay, you want to calculate this energy, this variation in mass. Approximately the answer will be 0.16. That is multiplied by 931.5 mega electron volt. Okay, which is approximately above 100, and it is 104, which is 104.7 mega electron volt. Okay, the binding energy is 104.7 mega electron volt approximately. Okay, this is just an approximated value. So from this option we can answer 104.7 mega electron volt. Okay, so we can move to the second question. The kinetic energy of photoelectron is increased by 4.52 electron volt. Okay, that means the kinetic energy is increased by giving an additional energy. Okay, increased by energy. Kinetic energy is increased by 0.52. When the wavelength of incident light is changed from 500 nanometer to another wavelength. Okay, so actually the initial wavelength is 500. Okay, what is mean by addition of energy? Energy is nothing but E is equal to h nu. That means energy is proportional to nu. That means frequency. Okay, and energy is inversely proportional to lambda, wavelength. So E is equal to hc by lambda. That means when lambda increases, energy will decrease. When energy increases, lambda will decrease. Okay, so when the question is saying that the additional energy is given, okay, by giving additional energy, the new wavelength should be less than 500 nanometer. Which option is correct? First option is 1250 nanometer, and second is 1000, and third one is 700. So 400 is the only one and only choice we have from the options, because by giving energy, the frequency will get increased. Okay, by increasing the frequency, the wavelength get decrease. Okay, so the new wavelength is 400 nanometer. Option D is the correct answer. So the third question is, which of the following radiation is deflected by electric field? Okay, gamma, X-ray, neutrons. Okay, neutrons has no charge, so electric field can't contribute any kind of force. In gamma radiation and X-ray radiation, it is an electromagnetic radiation. Okay, no mass is there. And alpha particle, what is mean by alpha particle? Alpha particle is nothing but the nucleus of helium atom. Okay, the nucleus of helium atom. So it has mass. Okay, and it has charge. Nucleus consists of positive charge. Okay, that can be easily deflected by electric field. Okay, positive charge can be easily deflected by electric field. So option 2, option B is the correct answer. So we can move to the next. The work function of a metal is 1 electron volt. Okay, work function phi is given. Phi naught is given 1 electron volt. Light of wavelength 3000 angstrom, okay, is incident on this metal surface. Okay, the velocity of emitted photoelectrons will be. So we want to find the velocity. So we want to relate the velocity with the wavelength. Okay, so which equation connect energy and this kind of which equation connect energy and this wavelength? We know that energy is equal to h nu, that is hc by lambda. So we don't want to do this all calculation. In the previous section I have given a compressed equation. Energy E is equal to 12,400 divided by lambda. Okay, that wavelength in angstrom. Okay, so the energy E is equal to 12,400 divided by lambda is 3000 angstrom. So divided by 3000, which gives 124 by 3 is approximately 125 by 30 is approximately 41.333. So 4.133 is the electron volt of this energy wavelength. Light of wavelength is incident. So total 4.133 of electron volt of energy is coming, and work function is 1 electron volt. So 3.133 of electron volt of energy is transferred to 3.133 of electron volt is transferred to the kinetic energy, contribution to the kinetic energy of the photoelectron. Okay, so how much energy we want now? We want to transform this electron volt to joule. Okay, so in order to that, we can just divide the 12,400 divided by in order to find what we have to find we have to find the velocity. So we want to divide the 12,400 divided by 3.133. So E is equal to 3.133 is equal to not E, kinetic energy half mv square is equal to 3.133 electron volt, and the electron volt should be transformed to 1.6 into 10 raised to minus 19 joule, and v square is equal to 2 into, therefore 6.266 into 1.6 into 10 raised to minus 19 divided by mass 9.6 into 10 raised to minus 31 kilogram. So approximately this can be cancelled, and 31 minus 90 is 30 minus 18, 20 minus 80 is 10 raised to 12. So V is 10 raised to 6. Approximately we can say that the velocity is 10 raised to 6 because the energy is 3.133 electron volt. Okay, just multiplied by the charge of an electron, we get the electron volt energy in joule. Okay, that joule energy is equal to half mv square. That means the kinetic energy of the photoelectron. Okay, then we only want to derive the format for the v square. So v square is equal to, just do the calculation and cutting approximation. Okay, then 10 raised to minus 19 divided by 10 raised to minus 31 gives 10 raised to 6. So 10 raised to 6 meter per second is one and only one option, and the other options are very far away from this 10 raised to 6. So we can conclude 10 raised to 6 meter per second. So option D is the correct answer. So moving to the fifth question. A proton moving with a momentum p1 has a kinetic energy 1/8 of its rest mass energy. Okay, p1 the momentum p1 has the kind 1/8 of rest mass energy. Another light photon having energy equal to the kinetic energy of the, that means equal to the kinetic energy of the initial particle. Okay, initial particle is proton and the second particle is photon. Okay, so we want to incorporate two kinds of equation. First one, energy equation related to a particle, and the second one, energy equation related to a photon. Okay, so and the second momentum is the p2, which is the momentum related to photon, and the p1 is the momentum related to proton. Okay, then we want to calculate p1 minus p2 by p1. Okay, the p1 and p2 both are momentum, so the p1 minus p2 by p1 is just a number. Okay, then we can calculate that. So first sentence is kinetic energy is 1/8 of its rest mass energy. That means the kinetic energy is p square by p1 square by 2m, which is equal to 1/8 of mc square. Okay, so 1/8 of rest mass of energy, mc square. Mc square is the equation for rest mass. Okay, energy of rest mass. Rest mass is m is the rest mass. Okay, so m into m is m square, and 2 into m, 2m square by 8 is m square c square by 4. So p1 square is equal to m square c square by 4. So P1 is equal to mc by 2. P1 equal to mc by 2. Put that in a box. Okay. Next we can calculate about P2. What is P2? P2 is, I already said that the second one is photon. So the equation connecting the photon is hc by lambda is the energy, and that is equal to what? P2 hc by lambda is equal to mc square by 8. Okay, that then the c and c can be cancelled because another photon having energy equal to the kinetic energy. Okay, the kinetic energy is what? 1 by 8 of rest mass. Okay, so c and c can be cancelled. So P2 is equal to mc by 8. Okay, so P2 is mc by 8. Then P1 minus mc by 2 minus mc by 8 by mc by 2. This and this can be cancelled. 1 minus mc by 8 divided by mc by 2. 1 minus 2 by 8, which is equal to 1 minus 1 by 4, which is equal to 3 by 4. Okay, so by this calculating these calculations, we can say that that is 1, and by using this calculation which is 1 by 4. So 1 minus 1 by 4 is 3 by 4. Okay, so option D is the correct answer. 1 minus 2 by 8 is equal to 1 minus 1 by 4, which is equal to 3 by 4. Okay, then we can move to the next question. According to Einstein's photoelectric equation to the graph between kinetic energy of photoelectrons ejected and frequency of incident radiation. So they are actually asking to us to find which graph is the correct graph which relate frequency and kinetic energy. We know that what happens in a photoelectric effect. A photon of specific energy means frequency, is coming to the metal and striking with an energy. Some energy is deployed, okay, and the rest of energy is given to the electron. So photoelectron. So energy is coming, some energy is deployed on the surface, and some energy is given to the electron. Okay, so but we know that a minimum energy is needed by the photon to eject an electron. Okay, so look to these graphs. A minimum frequency, that means minimum energy called minimum frequency. Minimum frequency is given in which graph? Option D, minimum. Then after that, increasing the frequency, the kinetic energy will increase. Okay, so option D is the correct one. So we can move to the 7th question. Energy of an electron in the second orbit of hydrogen atom is E2. The energy of electron in the third orbit of helium plus, so hydrogen, helium. And energy of electron in the second orbit, so hydrogen, helium. Orbit is second, and orbit of helium is the energy of electron in the third orbit, so helium is third. Okay, and the atomic number for hydrogen is 1, that means the Z, and the atomic number for helium is 2. Okay, so they are asked the ratio between E2 and the energy of helium. Okay, so how the energy of helium is related? We know that energy is equal to minus 13.6 electron volt multiplied by Z square by N square. Okay, while changing the Z atomic number, the energy will change. By changing the principal quantum number, the energy will change. Okay, so we can calculate the energy for hydrogen atom, which is E2, which is 13.6 electron volt, Z is 1 and N is 2, divided by 2 square is 4. Okay, so E2 is minus 13.6 electron volt by 4. Okay, then this is for hydrogen, and we can calculate the helium for the E3. So minus 13.6 electron volt into Z is 2. So multiplied by 4 and divided by n square. N is 3. So that is 9. Okay. So minus, okay, we can stop it by here. So the minus 13.6 into 4 by 9. E3 is, so energy of this is asked by them. That means energy by the helium atom. So how it is related to E2H minus 13.6 electron volt. So actually we need to multiply this by 4 then divided by 9. Okay, then only, no, we want to multiply again by 4 because the first 4 will cancel by the denominator and the second 4 will contribute to the numerator. So and then divided by 9 gives this 9. Okay, so E is equal to E2 into 16. 4 into 4 is 16 by 9. Okay, so what is the reason? The first 4 will cancel out this 4 and the second 4 will give contribution to this 4. Okay, so total 4 into 4, 16 divided by 9. So E is equal to E2 into 16 by 9. 16 by 9 is option B is the correct answer for the 7th question. Okay, so we can move to the 8th question. An electron in an excited state of lithium 2+. Okay, so what is the atomic number of lithium? It is 3 and ion has angular momentum 3h by 2 pi. Okay, angular momentum is given 3h by 2 pi mvr. The de Broglie wavelength of electron in this state is p pi a0. So we want to find p. What is a0? A0 is given Bohr radius. Okay, so what we have to find the value p, and what is that? The de Broglie wavelength. So we want to use the de Broglie wave equation, that lambda is equal to h by p. De Broglie wavelength lambda is equal to h by p. What is p? P is momentum, so h by mv, and they have given the value of angular momentum. So we want to create an equation of angular momentum inside this equation. I am just multiplying r by the numerator to the numerator and the denominator. Okay, then the denominator comes to equation of angular momentum. So that will be equal to hr by mvr is the angular momentum, that is 3h by 2 pi. 3h by 2 pi. Okay, h and h can be cancelled. So lambda is equal to 2 pi r divided by 3. And what is radius? R. R is the radius of the charged particle which is revolving. That can be connected with the Bohr radius a0. 2 pi by 3 and r is a0 z by n square. And what is n? That is n is 1. So z is 3 and z by n square, which is equal to 2 pi by 3 a0 into 3. 3 and 3 can be cancelled and 2 pi a0 is the lambda. So what is p? P is 2. Okay, because the standard formula is standard given expression. Okay, standard given expression for the lambda is p pi a0. So p is 2. So which option? Option B is the correct answer, 2. Okay, so we can move to the next 9th question. Which graph in the following diagram correctly represent the potential energy of a pair of nucleons as a function of their separation? See, the unit are in mega electron volt, because we know that the binding energy for one nucleon, the energy created by the one nucleon by its mass is 950 mega electron volt. So always the energy is in the unit of mega electron volt. First thing. So we can delete this option and this option. Both are in electron volt and kilo electron volt. Okay, so in option A it is mega electron volt and in option D it is mega electron volt. Okay, and the x-axis in Fermi, so that can be correct. But please look to the structure of these two diagram. And in this structure, the particle can be located at this at dip. Okay, the particle can be located inside the dip. So high energy to be given to escape, and high energy, very high, infinite energy of high is needed to change the particle from this position to this position. That means a constrained path is created for the particle. That means that particle is placed in a bounded region. Okay, particle in a box, like similar case. Okay, particle is bounded in a constrained path. Okay, so option D is the correct graph, which represent potential energy of a pair of nucleons as a function of their separation. If the particle is come nearer to the nucleus, then it can be repelled by a high force, and if the particle is going away from the nucleus, then it can be attracted by a force. Okay, that is represented by the option D. Okay, so we can move to the 10th question. In a nuclear reactor, heavy nuclei is not used as moderator, because heavy nucleus is not used as moderator. What is the function of moderator in nuclear reactors? The moderator will attract the neutrons, extra neutrons created by a nuclear reaction. We know that nuclear reactions are chain reactions, that once they started, they will end by completing all the elements. All the reactions happen to each and every elements. Okay, every atoms. Okay, this can be only stopped by absorbing the neutrons, extra neutrons. Okay, so neutrons are coming with very faster. So if there is an atom of heavy mass, then by momentum conservation it can be strike and it can be go away. Okay, it can't be absorbed. Okay, so is to be absorbed, we are not supposed to use heavy nuclei. So which option is the correct option? They will break up. Elastic collision of neutrons with a heavy nuclei will not slow them down. The net weight of the reactor would be unbearably high. Substance with a heavy nuclei do not occur in the liquid or gaseous state at room temperature. Option D is incorrect, option C is incorrect, and option B already discussed that nuclei will not slow them down. Okay, that by momentum conservation they will strike and they will go with a heavy velocity, and that neutron can be caused to next nuclear reaction. So nuclear reaction can't be suppressed. Okay. So moving to the next question, 11th question. In a photoelectric experiment, if both the intensity and the frequency of the incident light are doubled, then the saturation photoelectric current. So which factor is depend upon the current? Okay, what is the saturation current? Means the stopping potential, which the current we have to use a current to stop that photoelectrons. So that potential, what is the value of that potential? Okay, so saturation photoelectric current, so that current to be stopped by another current of electrons. So we need to calculate what intensity and frequency, how these quantities are depend upon the current of the ejected electrons. So what is meant by current? Rate of change of charge. That means it depend upon the number of ejected electrons. Okay, which quantity will increase the number of electrons, frequency or intensity? Intensity means what? Number of photons per unit area. So that means if we are saying the intensity is increasing, what? The number of incident photons are increased. Okay, so number of incident photons are increased, that means the number of ejected electrons are increased. Okay, so number of ejected electrons are increased, the current get increased. Okay, what happens if the frequency get increased? If the frequency is increased, if the frequency get increased, okay, the energy of each electrons, ejected electrons get increased. Okay, that means the frequency of the ejected electron get increased, that means the energy increase. That means the potential get increased. That means the stopping potential get increased. Therefore, when the frequency is related to stopping potential and intensity is related to current. So inside the question, in photoelectric experiment, both the intensity and frequency, they are increasing the both intensity and frequency of the incident light are doubled. So both are get doubled. Then the saturation, but they are only asking with the current. So current also get doubled and the potential also get doubled. But in here they are only asked with the current. So option A is doubled. Okay, electric current is doubled. Okay, and option 2, 3, 4 are all are correct. And someone will try to answer becomes 4 times. That is incorrect. Okay, because the current only depends. The current get depends by the intensity and the potential is get depends by the frequency. Okay, bye.